If we keep looking at these compounds, we're going to classify compounds as either ionic compounds or molecular compounds. Ionic compounds are composed of cations and anions. So one of the things we have to do is use our knowledge of the periodic table from chapter 4 to figure out what kind of cation, what kind of anion that we have. So in other words, we already know from chapter 4 how to determine the charge of the cation and the charge of the anion. So as an example, if we made a compound out of barium and fluorine, so we have two different elements, we find barium on the periodic table, and it's a main group metal in group number 2, and the last digit of 2 obviously is 2, so we know when barium forms an ion, it will form a positive 2 cation. Fluorine is found in group 17, and remember, you take the last digit of the group number for nonmetal, subtract the magic number 8, 7 minus 8 is a -1, so fluorine as an anion makes a -1 ion. What's very important to remember is that the overall charge must be neutral. The charge of every compound has to add up to a total of 0. And one of the ways we can figure this out is by doing a technique called crisscross. I'm going to write in the 1 in the 1 minus, even though we don't normally do that. The number of the cation comes down as a subscript on the anion, telling you how many you need. And the number on the anion comes down as a subscript on the cation. So if we put that together, we need 1 barium to neutralize the charge of 2 fluorines. And just like before, we don't include the subscript of 1, so we write this as BaF2. For another example, we can make an ionic compound between magnesium and sulfur because we have a group 2 metal again. Magnesium makes a positive 2 cation. Sulfur is a nonmetal in group 16. Take the last digit 6, subtract 8, and you get a -2. Do your crisscross technique, and in this case we're going to get a 2-to-2 ratio, and this is only for ionic compounds can we simplify that. In other words, a 2-to-2 ratio is not the smallest ratio of cations to anions that will be the correct formula. So if we divide both of those by 2, we would get 1 magnesium for every 1 sulfur. So you can make an ionic compound out of something that makes positive charges and something that makes negative charges. You will never be able to make this add up to 0 if they both form cations or if they both form anions.